Good day everyone. In the last video, we have seen how to integrate sine squared x, cos squared x, sine cube x, cos cube x. Now let us see how to integrate sine power 4x dx and cos power 4x dx. Okay, I will do one and you can do the other in the similar manner. Now let me take I is equal to integral sine power 4x dx. You can write sine power 4x as sine squared x the whole squared dx. Okay. Sine squared x you know how to write as a multiple angle using half angle formula. So I can write this sine squared x as 1 minus cos 2x by 2, then a whole squared dx. Okay, sine squared x is 1 minus cos 2x by 2, then that whole square. Now the 2 in the denominator, when you square, that will become 4. I can take 1 by 4 out. So I am taking 1 by 4 out. Then this 1 minus cos 2x the whole square is like a minus b the whole square. So I am writing 1 plus cos squared 2x plus 2 cos 2x dx. Minus 2 cos 2x dx. So now you have got here 3 terms. In this, the first and the third you can integrate directly. But coming to the second one, it is again a cos squared. So once again let me apply the formula. So I will write that 1 by 4, 1. This cos squared 2x can be written as 1 plus cos 4x by 2. Okay, because cos squared x is 1 plus cos 2x by 2. So I am getting 1 plus cos 4x by 2. I will write the third term as it is. Then I am having a dx. Now it will be easy if you properly take LCM and arrange the terms. Okay. So now let us take 2 as the LCM here. So here 2 ones will be 2. That 2 plus 1 will be 3. So let me write 1 by 4. Then integral. I will get in the number part 3. Then here I will get cos 4x. Then this will become now minus 4 cos 2x whole by 2 dx. Okay, that is we have taken 2 as the LCM. We have combined the 2 number terms and we got like this. Now this 2 can be taken out. So you will get 1 by 8 outside. Now all the terms are easily integrable. So now I will be getting 1 by 8. I will put a bracket. First I have a 3. You know whenever you have a constant, you have to just put 1x. 3 means 3x. When you integrate 3 dx, it is 3x. 4 means 4x, like that. So here the first term will be 3x. Coming to the second one, you have cos 4x. So you will be getting sine 4x by 4. The next one, minus 4 you write as it is. For cos 2x you will get sine 2x divided by 2, close the bracket, plus c. Now this 2 and this 4 you can cut, you will get like this. So the final answer will be 1 by 8 into 3x plus sine 4x by 4 minus 2 sine 2x plus c. Is this clear? So sine power 4x you are writing it as sine squared x the whole square. You are using for sine squared x this multiple angle formula 1 minus cos 2x by 2. Then the numerator you use a minus b the whole square and expand. And again there is one cos squared 2x term. There you use again 1 plus cos 4x by 2 that formula. Then you are integrating. In the same way you do cos power 4x dx so that this model will be clear to you. Okay. There are few more sums I have to teach you using trigonometric formula. But before that, you need to know another method or another concept, and then we will do those sums. So now I am going to teach you integration by substitution. This is very important, I will say. Now in differentiation, you learned function of a function or chain rule that you used in many other differentiation sums, isn't it? Similarly, this substitution is a method in itself and it will form part of sums which we are going to do later. So this is very important, you should understand it clearly. So now let me start with simple examples, then I will give you an idea what you have to substitute. Okay, so now let us see the first sum. I is equal to integral log x the whole squared by x dx. If you look at the terms, you have a log x within bracket and you have 1 by x dx. You know, if you differentiate log x, you will be getting 1 by x, isn't it? So, if you substitute whatever is within the bracket, you are able to get the other part in the sum as the differentiation. So, for such type of sums, you substitute log x is equal to some other variable. I am substituting log x is equal to t. Okay. Here, the next important step is, once you substitute, the next step is to differentiate. Never forget it. So, even though differentiation is over in term 1, you should now remember all the differentiation concepts also here. So, now, if I differentiate log x, I will get 1 by x. T means I will get dt by dx, right? Now, bring the dx here. So, you will get 1 by x dx. That will be equal to dt. Okay? So, log x is t. You differentiated both sides with respect to x. So, 1 by x is dt by dx. Bring the dx here. 1 by x dx is dt. Now, the given sum is in terms of x. And we are going to integrate with respect to the variable x. Now, we are going to convert that sum in terms of t and dt. Okay. So, now I will write my I is equal to integral. Log x is t. So, I will get a t squared, right? Then you have 1 by x dx which is equal to dt. Now, see, you have got the same sum converted into the variable t, and now this is a very easy thing for you to integrate, isn't it? The integrand is a simple one here. So, you know, when you integrate t square with respect to t, you will get t cube by 3 plus c. But this is not the answer you can give, because t is the variable we have substituted. One can put t, another one can put u, another one z, like that. So, now the answer should be in terms of x only, the final answer. So, now for t, you again replace it by log x. So, you will get log x the whole cube by 3 plus c. Do you understand? I think this is simple enough for you to understand. Now, let us come to the second sum. Here, integral x root x plus 2 dx. Generally, we will be substituting whatever is inside the square root, whatever is in the bracket, whatever is in the angled part, like that. As and when I do the sums, no, you will understand these things clearly. So, here x plus 2 is within the bracket. So, I am going to substitute x plus 2 is equal to t. Now, I have an x here. When x plus 2 is t, that implies x is equal to t minus 2. Okay? Because for each term, you cannot have half the terms in x and half the terms in t. You have to totally convert the sum in terms of t and dt. Okay? So, like that we have to see. So, now I will get, if I differentiate, dx is equal to dt, right? So, now you have got x plus 2 as t, x as t minus 2, and dx is equal to dt. So, now let us write our I will be equal to integral. This x becomes t minus 2. This root x plus 2 becomes root t. Dx becomes dt. This type of sums you have already done, isn't it? So, now You have one term here, so you remove the bracket. So t into root t will be t power 3 by 2 minus 2 into root t is t power half. Then dt. Okay, I have multiplied the two terms within the bracket by root t. Now you know you can use the formula integral x power n dx and you can integrate. So here you will get t power 5 by 2 by 5 by 2 minus 2 into 2 power 3 by 2 by 3 by 2 plus c. Now you have to remember two things. First you reciprocate these two fractions. Then for t you have to write x plus t. Okay. So now I will get 2 by 5 t is x plus 2 power 5 by 2 minus this will become 4 by 3 x plus 2 power 3 by 2 plus c. Are you clear with the two sums? So one sum I have taken so that you will substitute whatever is in the bracket as t. In the next sum I have taken, I will substitute whatever is within the square root as t. Okay. Let us see the third sum. I is equal to integral x by e power x squared dx. Here the exponential function, what you have as the power exponent, x squared. And you know, if you differentiate x squared, you will be getting 2x dx. And you have an x dx here in the numerator that is related to that differentiation part. So sometimes like this we will substitute whatever be in the power. Okay. So now I will put x squared is equal to t. Then if I differentiate I will get 2x. 2x is equal to dt by dx. I want only x dx because I have an x dx there. So I will write x dx is equal to, bring the t here, half dt. So like this, sometimes the numerator part along with dt, along with the dx will be something related to dt, 2 dt, half dt, 1 by 3 dt, like that. Now let us write I is equal to integral. First I am coming to the denominator, that is e power t, because x squared is t, that is e power t. Now see the numerator, x dx, that is half dt. Write the half outside the integral, put the dt here, right? You know, you cannot integrate keeping anything in the denominator. So now let me write it as half integral e power minus t dt. So when you integrate e power minus t, you will get half e power minus t by minus 1, because the coefficient of t is minus 1 plus c. Now let us write it properly. And then let us replace t by x squared. So this minus, so I can write minus 1 by 2. Okay. Then e power minus x squared plus c. I can leave it like this, or I can write this in the denominator as e power x squared. That is, I will be getting minus 1 by 2 e power x squared plus c. Okay. So in the third one, we have substituted the exponent as the t. Let us see the fourth sum. You have I is equal to integral cos root x by root x dx. Here see the angle part. The angle part is root x. If you substitute root x as t, if you differentiate, you will get 1 by 2 root x dx is equal to dt. So here you are going to substitute the angle part. So note in each sum what we are substituting. Okay. So now you put now root x is equal to t. If you differentiate, you will get 1 by 2 root x. Do you remember how you get 1 by 2 root x? In differentiation we have studied all these things. Root x is x power half. So when you differentiate, it is half into x power minus half, which you can write it like 1 by 2 root x. That is equal to dt by dx. Now you want only 1 by root x dx. So you can write 1 by root x dx will be, the 2 will go here. You will get 2 dt. Okay. So now your I will be equal to integral cos t. This becomes cos t. this 1 by root x dx becomes 2 dt. Put the 2 here. You will get a dt. So you got 2 integral cos t dt. So this is a straight function. You know the integration of cos t, that will be sin t. So you will get here 2 sin t plus c. What is t now? Root x. So sin root x plus c. So in the 4 examples I have given, in each one I have substituted a different thing. So you have to look at the numerator and the denominator properly and then decide what to substitute, so that all the other terms will be able to convert in terms of that new variable t, and the dx along with some other term will be related to dt. So actually I will give a few sums which I will show you how to identify what to substitute, because once you substitute, no, the sum is easy only. So like that I will take certain sums from the textbook itself and I will give you the hint what to substitute. That alone we will discuss. I am not going to do the whole sum. Okay. Shall we see few sums in which we will identify what to substitute? Okay. E power tan inverse x by 1 plus x squared dx. You should now remember e power. In that power, what do you have? Tan inverse x. So you have to substitute tan inverse x as t, so that you will get, if you differentiate that 1 by 1 plus x squared, that is the differentiation of tan inverse x, you will get that as some dt and you can proceed. Okay. Go to the second one. Cos x by root of 1 plus sin x dx. Remember, whatever is within the square root, we have to substitute. So substitute 1 plus sin x as t. What will happen when you differentiate? Cos x will become the differentiation, isn't it? So cos x dx, that will become dt. So you can proceed further easily. Coming to the third one, cot x, log of sin x. Within log, you have sin x. So if you substitute that sin x alone, you don't have a cos x here. So here I am not going to substitute that. I will substitute the whole term. Log sin x is equal to t. What will happen when you differentiate? When you substitute log sin x as t, 1 by sin x into cos x, that will be dt by dx. What is this? This is nothing but cot x. Bring the dx here. So now, if you substitute one term as t, the other term becomes either straight dt or it may be related to dt. So in the third one, you should not substitute only sin x. We have to substitute log sin x, the total term, as t. Coming to the fourth one, what is in the bracket? 1 plus cos x. Put 1 plus cos x as t, so that when you differentiate, you will get minus sin x. That minus you can take always outside the integral, that is not a problem. So substitute what is there within bracket as t here. Okay. Coming to the fifth sum, that looks a bit big, isn't it? Don't be afraid. Now let us see the sum. X cube sin, that angle part is tan inverse x power 4 by 1 plus x power 8 dx. So I have told you sometimes you have to substitute the total angle part. So here, if you substitute tan inverse x power 4 as t, when you differentiate, you will get, when you differentiate it, 1 by 1 plus x power 8, that is x power 4, the whole square is x power 8, into x power 4, the differentiation is 4x cube, that is equal to dt by dx. You have x cube and you have 1 plus x power 8. So x cube by 1 plus x power 8 dx will become 1 by 4 dt. So this sum, you are substituting the total angle part, that is the tan inverse x power 4 as t, and then you get like this. Then you can proceed easily. So now actually you have to try all the sums in NCERT textbook 7.2. Definitely you will be able to do. If not, please write it in the comment section, or you can contact me in my number I have already told you, 98414 So, in substitution, actually using substitution, there are some formulae derived, because you can notice when I gave you the first 16 formula, we have not have there any formula for tan x, cot x, cosecant x or secant x. Actually, using substitution and some other simplification, we will get the formula. So straight away I will give them 4 as a formula for you. So you add them along with the 16 formula, and then using that we will do something in the next video. So now let me give you the 4 formulae for you now, right? Just the 4 formula, let me tell you. Integral tan x dx is log mod secant x plus c, or you can write it as minus log mod cos x plus c. Okay. Integral cot x dx is log mod sin x plus c. Integral secant x dx is log mod secant x plus tan x plus c. Integral cosecant x dx, we have 3 different formulae. You can use any one. Log mod cosecant x minus cot x plus c, minus log mod cosecant x plus cot x plus c, log mod tan x by 2 plus c. So add these 4 along with the 16 I have already given, and definitely be very thorough with all these 20 formulae first for the first 3 exercises. Then of course you will learn few more formulae. So now in the next class we will be going to see some more trigonometry sums using the substitution concept also, and some other different sums. Okay. So if you like the video, share it with your friends. Thanks for watching the video.